if we want to wait for more people. But in the interest of time, let's kick it off. So my name is Kent Fourie. I am calling in from Cape Town, South Africa. So I'm also based in Africa. And I am going to be doing a talk on the Graph protocol. So in the chat, please maybe emote or say, if you know or don't know about the Graph protocol. It would be great to have a kind of temperature check on if you guys know about the Graph protocol. If you don't, feel free to ask me questions throughout the session, and I will answer them as best as I can while I'm going. Otherwise, I will keep them till the end. But again, thank you very much for having me, Idris, and Web3 Africa community. It's a great honor to be able to talk about the Graph protocol and the greater ecosystem around the Graph protocol, which you'll learn a little bit more about. So I also am representing Graphica, which is a community that I lead, which is the African community for the Graph, as well as the Graph Builders DAO. So let's get into it. The Graph protocol. So the Graph protocol was built to solve a very, very important issue in Web3, right? It was built to handle the data that we collect and essentially to clean up and categorize the data into way more understandable and accessible APIs. More importantly, to make these APIs decentralized, because we have a decentralized blockchain, right? And the data is being stored in a decentralized way on lots of different nodes. But if we're going to make a protocol which is going to take that information and place it in essentially indexes, what are called indexes, which host these APIs, we need to also make that a decentralized protocol, because having all that data in a centralized API really does not push forward the dream and the ethos of blockchain and Web3. So the Graph protocol essentially created this protocol, which has really, I would say, two main facets at the most simplest level, right? They have these decentralized APIs, which are internally, and also what we build, it's called a subgraph. And what this subgraph is, right? It's a set of code, right? And you can kind of, a very simple explanation for it is that it is mapping the transactional data that is happening on the blockchain. If you go to Etherscan or one of these block explorers, if you go to a transaction, you'll normally see that there is lots of information there. And you'll also, if you open up the logs, which has all the events being emitted, that is the information that we have access to. And what we do is we take this information, and whenever we listen for specific things that are happening on contracts, and when certain events happen and when certain functions are called on smart contracts, what we do is we are listening to those specific ones, and we grab that information when it happens, and we create database entities. We update database entities, which we define, right? So that is the subgraph part of it, which is the essential rule set of how we take the data and what we listen to, and the database schema that we build, and how we create entities inside of this database. Secondly, we have the other side is the indexes, right? And what the indexes are is you can kind of think of them like a miner or someone who is running a server, right? And there are many, many indexes in the ecosystem. And what this indexer does is he runs this code, right? Because when you build a subgraph, you tell it to start indexing from a specific block, and then it grabs all the data continuously from that block in the past. And once it gets up to the latest block, that's what we say that the subgraph has synced entirely. And then it is going to be useful, because when you want to use a subgraph, you want to have all the information that's happened since the time that the smart contract existed, and you want to get the data that is the most the newest data, the most like up-to-date data that's happening. And what they do is they will take these subgraphs and they will essentially run lots of different subgraphs on their large servers, right? And host and sync them all up, and they make them available to the ecosystem to query, right? So if you have your subgraph and it's being hosted by 10 indexes, now you have that API, which is accessible in 10 different places around the world in a very, very decentralized way. Another thing to cover is that there is a token, a utility token within the Graph protocol called GRT, right? GRT token. I'm not sure if you know about it, but GRT is specifically a utility token because it is used by the indexes to stake a certain amount. They stake GRT to a subgraph for a few different reasons, and that's how they start indexing it, right? When people want to use these decentralized APIs, they have to actually pay for every single query that they make to the subgraphs, right? And these queries, when you go and call and get a piece of data, that one query is very, very cheap, right? And it works out to be, a lot of times it works out to be cheaper to host your, your data layer, this data layer for your application as a subgraph and spend your money on the query costs, as opposed to running a large ecosystem on, AWS, and that's what we kind of call a roll it your own indexer or a self-hosted indexer. And, the comparison is that, once you build the subgraph, it can be run in a very, very decentralized manner, and you won't have, there's very little chance of downtime, but you do have to pay query costs in GRT. And the other side of that is that you run a centralized API and you have to pay for everything around that. And you don't really have community support. You don't have to pay for query costs, but all of those sort of things add up in costs over time as well. Now, the reason why we use the Graph protocol, and I'm a Web3 developer, so I've been working as a developer in the blockchain ecosystem for quite a long time. And before that, I was a full stack developer, in lots of different teams, like enterprise, web, C# and that sort of stuff. But I've been in the Web3 ecosystem for a long time. And when I started, the Graph protocol didn't exist. And we had to make essentially these self-hosted indexes. And it was essentially the largest, most painful part about creating a dApp and building out a dApp and getting it deployed to production, because every single time you made a change to the database, you had to re-index it from scratch. If something went wrong, again, you have to re-index it from scratch. And because the blockchain is consistently creating transactions, you can't really have any downtime if you have a production level decentralized application, right? So in Web 2, obviously you can take backups of the database and all that sort of thing. Yes, you could do it here as well, but it doesn't really matter for the latest information. So what essentially the Graph protocol gave us is a huge time saver, and also a way to reduce all this technical debt, because we don't have to run a massive server. We don't have to make sure that our database is, working perfectly all the time. We don't have to make sure that our server is not running out of space and that our connections are running properly. And we also have this amazing set of tools and features in the Graph protocol, which really make indexing data much easier than doing it by yourself with all the tech. Obviously, you don't have to host your own decentralized API, which makes it much nicer. You can just deploy it, and you can let this suite of indexes handle it. Obviously, there are different parts to the Graph protocol. We have three different areas where you can deploy. You can deploy to the hosted service, which is essentially the service which is hosted by the Graph protocol itself, one of the teams. And that does not cost anything to query. It's really seen as a way for developers of subgraphs to test out their subgraphs and make sure that they're working before they deploy it to the studio, which is the next part. And in the studio, that is also hosted by the internal team, but it's kind of like a launch platform before they put it on the decentralized network, and they publish it to the decentralized network. Once they publish it to the decentralized network, it creates an NFT, which they own, which is kind of the way to show ownership over this subgraph. And you can update the versions of this decentralized version of the subgraph all the time. And then once it's there, the indexers can pick it up and they can start indexing it, right? Another great part about the Graph protocol is it's fully open sourced. So all the tools that you use when it comes to indexing, when it comes to building out subgraphs and substreams, we'll get into what substreams are soon. All that code is open source. So you can participate in in issues, and essentially a lot of the best team members of the ecosystem have been found by just, you know, they went and they saw the issue list on GitHub, and they took a stab at solving one of them, and they got hired. So there's a lot of opportunity for really great developers and people to use the decentralized, the open source code. So I want to talk a little bit about the core teams inside the Graph protocol. So it obviously started off just as the Graph protocol, and the main team inside the Graph protocol was Edge and Node. But over time, as these decentralized projects grow in size and in scope, they needed to do it in the right decentralized way. And the way that we do that is obviously to have a foundation which oversees lots of different teams which work on different parts of the ecosystem. So obviously we have the Graph Foundation, and the Graph Foundation really focuses on stewarding the ecosystem, making sure that grants are being issued to the different teams and to the different endeavors being built, as well as community support. Currently, the Graph protocol is doing like a campus tour in many different regions of the world. We're busy talking to someone on the ground in Nigeria to organize to go to different campuses as well, to go and talk about the Graph. But that's the Graph Foundation, and they essentially oversee all of these other teams. Next, we have Edge and Node, which was the initial team behind the Graph, and they are really focused on developing the decentralized protocols, and the hosted service, and making sure that decentralized protocols are working, and really working with these other teams to make sure everything is going really, really well. They also do have a lot of DevRels, which will go around and speak and teach about the Graph protocol. Next, we have Graph Ops, and they really focus on indexer experience, research and development, and the core development packages. I'm going to run through this a little quicker so we can get to the fun stuff. We have the Guild, right? And they are really focused on improving the GraphQL API and the subgraph tooling that we have access to. Masari, which is one of the newer teams, is really focused on subgraph standardization and the reporting side about subgraphs, getting data and reporting on it, getting data from subgraphs and reporting, and talking about, different metrics within the ecosystem. We have Semiotic Labs, which really focuses on taking AI and research and development around AI within the Graph protocol and Web3 and data on the blockchain. And then Streaming Fast, which really is the big team behind Substreams and Firehose, which Firehose is a piece of tech which allows us to really grab the information from the blockchain way faster than any other way, like way faster than remote procedure calls. And substreams are also a different way to collect the information and pipe that information into a subgraph. And we'll talk about the differences soon. Now, we also have many organizations within the Graph protocol which are funded by the foundation. And these, I'm going to talk about really the three main ones. And like, obviously, we can say, Afrika and some of the other communities are also, but those are essentially communities. These are the organizations which really are very focused on specific things inside the Graph protocol. First up, we've got the Graph Advocate Style, right? And this is an amazing place for anybody who wants to really, get involved in the Graph protocol and in advocacy on the ground where they're from. We've got many advocates from Nigeria and Africa, from Ghana, because there's communities like Graph Nigeria, Graph Ghana, and Graph Africa, obviously. And what they do is they essentially will oversee all these advocates. They will really oversee the issuance of community grants for different talks and different, endeavors that these advocates do, like translation of the documentation, different tools and write-ups that people do on the tech, and also on the different roles that you can have inside the Graph protocol. And it's really open to anyone with any sorts of skills, as long as you really have a good work ethic and a good attitude, and you can really become there's always new Graph advocates being onboarded. So it's a great place to be, to meet other people in the ecosystem, to work in Web3, and to really get involved with the Graph. And it's like the first place that I would say everyone should go if they would like to jump in and get involved with the Graph. Next up, we have the Graph Builders DAO, which is very newly formed organization that oversees the building of like very high quality subgraphs and substreams. And they essentially work on a bounty system where we post up bounties with a certain amount of money attached to it. And anybody who is validated with inside of this organization, right, they've been voted into the organization, has the ability to work on one of these bounties and earn. Now, these bounties aren't like just small little jobs here and there. They are some serious, like there's some really tough work, but that's why the Graph Builders DAO is seen as really the top team of the best, really the best in class builders of substreams and subgraphs in the world, right? We really are looking for the best guy, the best of the best guys to join this this Builders DAO, and we work with the top decentralized applications, like the top companies who need the Graph protocol. I'm not going to mention in names, but yeah, we really work with like the top of the top when it comes to the applications that we all use in Web3. And lastly, we have Indexer DAO. Now, Indexer DAO is an organization focused on the indexing side, and they really are a team of knowledgeable people who have been in the Graph ecosystem for a very long time, whether they've been in the advocacy group or whether they actually work for one of the teams inside of the Graph protocol. And they're really focused on the educational content and helping new indexers get into the ecosystem and helping them get set up. And it's a great place to go if you want to become an indexer. There's not many indexers in Africa, last time I checked, but you know, any of these groups. So if you want to just get involved with that, with the Graph protocol, look at joining the Graph Advocates DAO. I'll show you the website after this. If you are a Web3 developer, I would say get involved with some of the code, go and build your first subgraph. And in Graphica, we also are running a masterclass of workshops and to teach you how to build the best, like really high quality subgraphs. If anybody is keen on doing that, if they've got some TypeScript and Solidity experience, if they've been building in the Web3 ecosystem for a while, we teach that in Graphica, and that'll get you ready for your application into the Builders DAO. And then Indexer DAO, you can also join. All of these have Discords. You can join all the Discords, and you can go and chat in there and speak to some people and join some of the calls. All right, now let's talk a little bit more about the network roles inside the Graph protocol. We have essentially, we can break it up into 4 different areas, right? We've got developers, right, who really work on the substreams and the subgraphs, and their job is really to create and update, maintain, and deploy, very important, deploy these subgraphs and substreams, right? Next, we have the indexes, and we've spoken a little bit about this. They index the subgraphs on the network. They basically keep the network running. They stake GRT to these subgraphs, and they receive rewards in different ways from running these subgraphs. Curators. Now, curators are the ones that identify these high quality subgraphs and identify to the indexes which ones should be indexed, right? So they will take GRT and they will signal on subgraphs, and that will tell the indexes, okay, cool, these are the ones that I need to index. On the mainnet deployment of subgraphs, where curators are busy curating, by doing the curation, or it allows them to essentially own a share of that subgraph, which it's a tricky way, but you can actually like increase the amount that you curate with if you're smart on it, and you can essentially double or really increase the amount of curation that you put on it, just how the kind of economics around it work. But that isn't applicable to all the different places that you can publish. I'll explain that a little bit more later. And then lastly, we have delegators, right? So delegators are people who really, they own GRT as a token, but they want the GRT to work for them, right? Because everybody wants to like have passive income being made from their tokens. That's like really the golden standard, right? So if you have GRT, what you can do is you can delegate it to these indexes, and the indexes can use it to stake to different subgraphs, and that will essentially pay when these indexes do that, it will pay back to the delegators. And if you delegate your GRT to indexes, it will essentially passively earn rewards, and it will increase over time. All right, let's talk a little bit about subgraphs and the tech behind it. So we've got the stack of the subgraph is is a little bit different from a lot of code that people have used before. It is a assembly script, right? And it looks and feels exactly the same as TypeScript, but it's essentially a limited version of TypeScript. And that is what we write these mappings in. That is what we write the code that goes and grabs the data from these events or these calls that are being made and these transactions. And we basically will then go and create, update, and delete these entities, which we define in our schema, in our database. And we define the schema in GraphQL, right? It is also the query language for when you are querying these decentralized APIs, but we define the schema in GraphQL as well. And then lastly, we have the manifest, which is just a YAML file. And that is where we define the different contracts and events in those contracts that we want to listen to. We'll talk about the different things that we can listen to in subgraphs in the next slide, in a couple of slides. But the way that it works is we define these contracts, or what we call data sources, and which events we want to listen to, right? Or calls, or these different handlers. They're called handlers. So each of these events, right, will have a handler. So whether you have a transfer function on EOS on an NFT contract, or if you've made a custom mint, event, or if it's OpenSea, and OpenSea has like the match and execute event, which is the common one where if something is sold, those are the sort of events that we'll listen to on these different contracts. Now, each one of those events will have this handler function, is where you can actually write the code, and this handler function will have the event that is being emitted at that time given to you. So you have all the data on that event, and then you have access to the database where you can do all these calls, do all these operations, essentially what we call CRUD operations, create, read, update, and delete operations to this database, or store is a different word for the database. And the store is the schema that you define beforehand in GraphQL. The data that we have access to in these events are the full transaction, the full block data, and the event data for that event, right? But we can also get access to the transaction receipt, which is essentially all the other events that were emitted in that transaction. And once we deploy the subgraph, it starts syncing from the current block. And the reason why I say that current block is because when you deploy a smart contract, that is the block that you should start syncing it from. So if you think about like OpenSea or an NFT collection, if that NFT collection was deployed 4 years ago, it doesn't make sense for you to start listening for blocks recently, because it doesn't get all the information that you need. You have to start listening to it from when it was deployed, when it was created. So and then once it's actually gone through all the blocks up until the current block, we say that it is synced, and it does produce an API even when it's in those blocks back in in previous and historical blocks, but the data obviously isn't synced up to the current data that you can find on Etherscan. But you can verify if it's synced halfway up by looking at all the transactions and those sorts of things. Now, this API that it produces, you can query in GraphQL, which is a query language, which is actually quite a nice query language that you can use. It's different from SQL, but it's quite intuitive in the way that it looks and feels. Now, a little bit more about the technicalities around subgraphs. So we've got different subgraphs that can listen to different types of chains. So we obviously have the EVM style chains, Ethereum style chains, which are running Solidity. And those ones, we have event handlers, right? Which is obviously the ones that we talked about, the events that are in the smart contract. And these are kind of like the best in class to listen to, because they don't really have any impact on sync speed, and they are very, very, I would say it's the best way to do it, right? So if you have a smart contract ecosystem where you can listen to just only events and that'll get you all your data, that's great. But sometimes we can't assume that, and sometimes there are functions that are changing the state on chain. And really the goal is that we're trying to match the state that is happening on chain, right? We're trying to match what's happening on chain with this database that we're creating, this which is going to produce this API. So if there are functions inside the smart contract which do not have an event and they are changing state, we have to listen to them. So that is why we have call handlers. Now, call handlers are essentially the function call of the functions inside of the smart contract. So you can have a call handler and an event handler on the same piece of data. So, you know, an event is normally emitted at the bottom of the function, but the call is the actual entryway of the function. And the things that the data that we have access to there is the parameters being passed into that call. And obviously, if the call is returning anything, we have the return values. But we have, you know, the reason why we don't always want to use call handlers is because they do slow down syncing speed, and they add a little bit more complexity, because if you have, you know, events and call handlers that are emitting for the same set of information, you have to handle that correctly in how you're, you know, manipulating your database, because you know, there is an order to how things are captured inside of a subgraph. Lastly, we have block handlers, and these are, you really want to stay away from these if you're just running a stock standard block handler, because that'll essentially execute on every single block, which is going to really slow down your subgraph. You can obviously, there are some settings on a block handler where you can tell it to only execute on blocks where there were transactions against your contract, which again is not really it's not the best way to do things. It's not really advocated for. But there are two other types of block handlers, which is a polling handler, which is, these are very new ones, which is a polling handler. So that one will run like every X amount of blocks. So you can set that time span, which is quite nice for having like a data series. So you can run it like every epoch, which is 30,000 blocks. But you know, you have to obviously be very careful about how you're doing that, because if you're doing it every 100 blocks, it's going to slow down your subgraph. And then the initialization handler, which is like one of my favorite ones because it's brand new and it really is really helpful. And this is essentially a handler that runs like at the beginning. So it's like the minute that your data source of that contract starts running in the subgraph, this handler will run. It will only run once. So it's a great way to do kind of setup beforehand, to start creating like global entities and entities that, you know, you just need to create once. Initialization handler is a great way, very helpful in a lot of ways. We also have the ability to build subgraphs for near and Cosmos chain. We've got block handlers and receipt handlers for near, which essentially will run on every block, or it will run every time a message is executed at a specific account. So an account can be a wallet or a smart contract. And then with Cosmos, we have block, event handlers, and transaction handlers. So block and event handlers look exactly the same as the Solidity versions. And then transaction handlers will run every single time a transaction occurs, which is, you know, it's going to be a lot. Now, the other way that we have access to data sources is we have the ability to template, which is a way to dynamically track contracts, right? So this, you know, we said that we have data sources in your manifest file, right? So if we have one contract and another contract, what if we're tracking something like Uniswap, which is consistently deploying new Uniswap pools, right? So you can't obviously go and add all those pools in this data source file and then, you know, 5 more get created, then you have to edit, 5 more get created, then you have to edit. Doesn't make sense. The nice thing is that when a new contract is deployed on the blockchain, it will always run the same. So we can always expect the same sort of execution and functionality and logic to be executed in a contract deployed if it's the same contract deployed on the blockchain. So what we can do is we can listen to the event or the point where it is busy deploying that new contract, like a Uniswap pool. And what we can do is we can write out the code that is going to be responsible for new pools, and this will run for all of the pools ever deployed. And what we do is we grab that pool contract address and we say create a new data source. So we can dynamically add up to, you know, a few thousand or even more, as many as you want, of these data sources. And that allows us to dynamically increase the scope of our subgraph, which is extremely helpful. Another template that we have access to is something called file data sources. So with regards to NFTs and like Lens protocol, what we can do is we can grab the IPFS hash, like URI, and get the metadata from NFTs, or get like the posts on on Lens protocol, and we can go and query IPFS and Arweave data and take that data and put it inside of our database, inside of our store. So we have the ability to go and grab IPFS information and really collect everything that you need to serve information about, you know, your NFTs and anything that you've put on IPFS, because you have access to query that information. It pulls down the whole IPFS blob, and then what you can do is you can essentially take every little piece out of that JSON blob, because everything posted to IPFS is normally JSON. Obviously, we're not storing the actual images and videos and those sorts of things, but what we can do is have a reference to those images and videos that are on IPFS and Arweave. But what we can do is we can take all that nice metadata and we can store that, obviously connected to the original token. And even if there's an update to metadata, we can listen for that and update it. And the last way we can get information is by doing something called read functions. So view functions on smart contracts are available to subgraph developers inside of these handlers. So if you want to go and read the decimals or the symbols, or go and read the total supply on an ERC20 token, you can. And you can go and read specific view functions that are available on smart contracts within these handlers. It does slow down syncing and it does create an overhead for the indexes. But if you're doing it in a controlled and safe way, it is a great way to get more information about the ecosystem and to get like on-time information about the ecosystem. Now, substreams and subgraphs. We talked a little bit about subgraphs. Now let's talk about substreams. So substreams was born out of the need for composability and parallelized data sources, right? So the problem with subgraphs is they can't be composed with each other. If you have a subgraph, you've got another subgraph, it's a lot of work to go and push them together. You have to do that by hand with a lot of coding and check if everything's working properly. The ability to extract data is also limited. So we only actually have access to the event, the call, the block, and the transaction in subgraphs. Obviously also eth calls, but it's very limited. The syncing speed is very slow with subgraphs on very, very large data sets, right? So if you're syncing from, very, very early in the blockchain and there's a lot of entities being created, it's going to be slow. And the problem is that the language that we use is quite esoteric, and I would say it's quite unfinished. It's not the graphs protocol's fault at all, because AssemblyScript is a language created by, I think it was, can't remember exactly right now. I think either Facebook or Microsoft or something like that. But AssemblyScript is like a very hard language to use because it is it's quite esoteric. It doesn't have all the functionality that you would expect from a fully fledged language. And now what substreams allow is for the ability to process and store this blockchain information in a much faster way. You can really it is run in parallel, so they have parallelization. You can really compute in a horizontal way. So this horizontal scalability to allow for more compute power, whereas in subgraphs it's just like one stream. And because substreams are using a Firehose, we have the ability to use gRPC, which is a very, very fast remote procedure call to get information. And we're also using protobufs, which is actually, protobufs are protocol buffers, are a great standard used all over the internet. The nice thing about substreams as well is that it uses this MapReduce pattern, right? So you can essentially take information from the different data sources you have available and map them into different protobufs, and you can compose these different map modules and store modules with each other. You can even build a substream which then eventually pipes out to the GraphQL schema that we have in a subgraph. So instead of building out all the stuff in AssemblyScript, you do it with a substream, and then right at the end you push it out into a GraphQL into your database entities. And we have a lot more access. We have access to a lot more different types of data sources within substreams, right? We have access to like balance changes and the large blocks, as well as different types of calls, and we can really filter these quite nicely to get a lot more information than we would inside of inside of subgraphs. So a lot of the time we're just starting with we're starting with a full block, and we're basically trimming down that block information, which has all the information that's happened, down into the little different parts that we need in one module, and then we kind of compose these together. It's very, very functional, very, very clean. We even have the ability to listen to transactions that fail, essentially transactions on the mempool. So there has been amazing projects that have used this to great effect at hackathons. Now, the knowledge requirements for substreams are a lot different, right? You have to have experience with Rust, and Rust is a very, very, very powerful language. It's a C-based language. It is a lot harder than your Java and your JavaScript and your C#, in my own experience. But once you get into it, it's very, very you get very comfortable with it, and it becomes a lot of fun. You start running really, really quickly with the language. It has tons and tons of flexibility. And all you have to do is just go and learn, like go and do a little bit of time with like Rust by example or something like that, and you can learn Rust. But it's a great language. I recommend anybody who is a developer who hasn't jumped into it or just dabbled to jump into it. It's a great language, and it has a ton of power. You have to also understand protobufs. Now, protocol buffers are this open source cross-platform data format, which lots of different ecosystems use. And it's important to understand the data types that are available to you, like the block, the transaction, the log, the transaction receipt, and balance changes and those sorts of things. Also understanding this map reduce pattern is very, very important, because that's essentially 90% of what you're doing is taking and mapping the data, the larger sets of data down into smaller sets of data, and producing these more important pieces that you're looking for. I would say that you'd also need quite a little bit more blockchain knowledge than just your normal 101, because there's lots of differences, like between the different chains that you're using. You're going to need to go down into the rabbit hole of like all the data that is available. So if you have like simple blockchain knowledge, that's good enough. But I would always say jump into understanding a little bit more about how the blockchain works and what data is being created at the block level. Cool. So that was substreams and subgraphs and what we use to actually index the ecosystem, right? The essential building side of it. And now let's talk a little bit about the indexing side of it, and the curating side and the delegating side, which are kind of all connected in a way. So the graph protocol indexes real role is to index these subgraphs and substreams. They can't really index a substream, but a substream powered subgraph they can, because it produces a subgraph. They are essentially the miners in the protocol, as I've said before, even though they don't mine, but they do run lots of different blockchain nodes so that they have direct access to the blockchain all the time. And they store this data we index. So I know indexers who have massive servers, and they either rent them out, or they actually have big server rooms where they store this information, and they've got lots of compute power where they are running the code to sync these subgraphs. They also obviously are running Ethereum nodes and other blockchain nodes locally, because it allows them to connect directly to it and not do it over the internet to someone else's, like an Alchemy node or an Infura node, because they would pay a ton of cash if they had to do it that way. So it's better for them to actually run their own node locally. They obviously have to have a stable internet connection. And to be an indexer, you need a minimum of 100,000 GRT, which is about $8,000 US. Currently at current prices, I think. I'm not sure what the current GRT price is, but last time I checked, it was around 8 cents on the dollar. And the way that they earn is they get two different types of rewards, right? So there is something called an indexer reward, and this is a flat, this is an issuance that goes out every single year, right? So there is this reward that goes out because of from protocol inflation, and this is paid by the foundation and the other teams, and this is basically a 3% annual issuance. What happens is that the way that they choose how to get these rewards is that, remember, we have curators, right? And essentially this large issuance is paid out proportionate to the curation on subgraphs, and then next is proportionate to the amount that a indexer is staking to that subgraph. So as an example, if there were 2 subgraphs on the whole network, and this one, oh, how did I get the balloons? That's weird. If I had 2 subgraphs on the network, and this one had 10,000 GRT curated to it, and this one had 5,000 GRT curated to it, it means that this one would get half of the issuance that this one would get. And then if there was 2 indexes on the 10,000 one, right, then those 2 indexes, if the one has, let's say, 10,000 GRT staked, or it's normally a lot more, if they have 10,000 GRT staked and the other one has 2,000 GRT staked, right, the 10,000 GRT guy will get obviously 5 times more than the person with 2,000 GRT of that full issuance. So that's kind of how the issuance works. It's kind of divided up to all the subgraphs that have curation on them, and then from there it's divided by how much the indexes are staking on those subgraphs that have curation. And the next reward that they get is through query fees. So we spoke about how we access the network, and when you are accessing a decentralized API or decentralized subgraph, which is deployed and published, you have to pay in GRT to query it. And obviously, this will build up if there's tons and tons of queries, and these query fees are paid to the curator as well as the indexer. Now, there also is another cool thing inside of the graph inside the graph protocol for the indexes, and it's called the MIPS program, or the multi-chain incentivization program. And this is busy incentivizing the support of more chains, because it started off with just Ethereum mainnet, and then with the MIPS program, they started adding more and more chains like Arbitrum, Optimism, Polygon, lots of different ones. And like there was a program essentially to incentivize all of these indexes that are in the network to start hosting these other chains. And you can imagine that it's a lot of work to set up a different chain. You have to run that node. You have to, make sure that you have everything set up as for that separate chain, and making sure that it runs correctly. But this program is really there to help bootstrap more indexes to have more support for more and more chains, because the graph protocol is very, very chain agnostic. We support tons and tons of different blockchains. So it's a nice place to be, because you don't really have to pick and choose which blockchain you want to stand behind or use. There are lots of different blockchains being supported inside the ecosystem. Next role is delegators. And their role essentially really doesn't need to have a lot of technical expertise. They really, all you need to have is some GRT and some tokens. And they, whether you have a lot or whether you have a little, you can just choose reliable indexes to delegate to, because what indexers do is they can set how much of those the indexer rewards and query fees they want to split with the delegator. So that is always public knowledge. When you're looking at indexes, you can see, okay, this indexer is going to give me 20% of the fees, right? 20% of the query fees and 20% of the indexing fees. And every single indexer has a different one, which obviously creates a little bit of competition and economy around who's going to get the delegation, because delegation means that they have more GRT to use and more GRT to stake against subgraphs and more GRT to be able to earn those different rewards. You can use any sort of any amount of GRT, and there are some caveats though. When you do when you do delegate, once there's always this initial burn. So I think there's a small percentage which is burnt when you start delegating, which is not a big issue. It's how we run the protocol. And then once you've delegated, if you want to undelegate, it takes 28 days from when you actually execute that transaction to undelegate for you to actually withdraw your income, which is just a way to kind of protect indexes and protect you as well as delegator. And I've already spoken about the different percentage splits that you can receive from the indexes that you delegate to. Lastly, we have curators, right? And curators' role, as I said before, is to signal subgraphs to be indexed, right? And what they do is they take GRT and they pick a subgraph and they signal to it, right? And this will obviously, this will inform the indexes that this is a subgraph which is going to be earning part of that annual issuance, but it was also a high quality subgraph which they should index. Now, indexes normally won't index a subgraph that doesn't have any curation, doesn't have any signal. It doesn't really make sense for them to do it unless there's unless it has like a lot of use cases and a lot of importance. But like outside of that, you know, if it has a lot of use and it has a lot of importance, you'll have people curating to it. So it's kind of like, you know, that's how they identify the ones that they need to index. You can use any amount of GRT to curate, and by signaling, this produces a share in the subgraph. And these shares are produced along a bonding curve. So the first person, if you're the first person ever to purchase a share on of a subgraph by signaling on it, you're purchasing it for the cheapest amount, and then everybody afterwards is going to be purchasing it for more money, right? So that gives you a chance if you're the first one to purchase the share, and you know you have people purchasing after you along this bonding curve. If you sell it, then you will increase the amount of GRT that you will receive. So if you initially signaled with about 5,000 GRT, and then someone after you came and signaled with 5,000 GRT as well, I would have, you know, about 75% of the shares, and they would have about 25% of the shares, even though we paid the same amount. And I would be able to sell all my shares and get 75% of 10,000 GRT because we both put in 5,000, right? So you can see how people will actually play this game. And that is also, this is only applicable to when you are publishing to the Ethereum mainnet. So as I said, remember when you publish a subgraph, it creates an NFT, right? And there are two networks where you can publish a subgraph, and that is mainnet and Arbitrum 1. And this is only applicable for mainnet. Everybody is now starting to move over to Arbitrum 1 because the transaction costs are way cheaper, the query fees are a lot cheaper, and the curation signal is flat, which takes away this whole game that people can play with curators. So a lot of times when someone sees that there is curation on a subgraph already, that it keeps them from actually curating more on it because they're scared that someone's going to sell underneath them. And it's happened to me before, and it sucks because, you know, my curation of 8,000 GRT became like 3,000, and it's a bad feeling. But now, obviously, on Arbitrum 1, it's a flat curation. It's a flat curve. So, you know, on mainnet, the curve would look like this. And you would essentially purchase underneath this curve. Now, publishing subgraphs to the centralized network looks like this. So when you can publish to, as I said, to mainnet and to Arbitrum 1. And on Arbitrum 1, there's a flat curation curve, so no one can hurt you if you signal after them. There's a lot cheaper transaction costs, and rewards for indexes are there. They're not coming soon. I had to change that. They are now here. There are obviously certain caveats for newer features. So for certain features, rewards are paused, but rewards are implemented. They're not coming soon. They're implemented now. We have obviously then mainnet, which is the first network where we could publish and deploy subgraphs to. And this obviously has that linear curation curve, and rewards have always been available to indexes. The other part is we have these API keys which you can generate, right? And these are essentially the wallets that it's almost like a little bank balance that you create with this API key, because what you do is you fund it with GRT, and that little API key is what you can use to insert into that API address to query, and that is where it is going to essentially take money from. So you fund these API keys, which will then pay for your query costs, right? There's, you know, you can just fund it with GRT straight up with crypto wallet, or you can actually use traditional fiat currency with banks. So you add your bank information and the fiat currency of your choice, and it will basically take it off your card. And you can essentially take these API keys can be really secured against a specific domain and against a specific subgraph. So like I'll show you after this, there is a specific website where I'm using a subgraph which I built, and that API key that is there, anyone can see it. Obviously, if they go into like the network tools, if they just inspect, and they will be able to see it, but they won't be able to use it because it is only for my website, and it can only go to my subgraph. Right? These are all the different chains that are available inside the ecosystem. These are on the decentralized network currently. We've got Ethereum, Gnosis, like XDAI, you know, Arbitrum One, Optimism, Polygon, Phantom Opera, Celo, and Avalanche, and more are getting added all the time. We've also got private networks on the decentralized network, which is like Polygon, CK, Zero Knowledge EVM. We've got Zero Knowledge Sync Era, and we also have Base. So Base is obviously that Coinbase network, which is on the decentralized private, which is a little bit different, where you can deploy it and it's not available to everyone, because if you deploy to the decentralized network, everyone can see the API. And then we've got lots of decentralized test nets on as well. So like lots of test networks, which are also on the decentralized network. And when I say decentralized network, I mean the Graph Protocol decentralized network, right? We have the hosted service, which I mentioned before, which has all of the ones mentioned inside of the decentralized network, as well as these over here, which are not supported on the decentralized network. For, you know, it's a place where we kind of test out the different networks before they go to the decentralized network and make sure that they're working properly. And, you know, all of these chains are supported except for Base, Polygon's Zero Knowledge EVM and Zero Knowledge Sync Era, as well as Ethereum Sepolia. I think Ethereum Sepolia is now again on hosted service, but for a while it wasn't. And that is my talk for today. If you have any questions, please feel free to ask them, and I'll hopefully can answer them for you. But before I go, I just want to show you some website links. If you want to learn more about the Graph Advocates, you can go to graphadvocates.com, indexitdao.com, and also buildersdao.tech if you want to read up about it or apply. And this is what a subgraph looks like on a decentralized network that I built, right? So this is a CryptoPeppers one for a CryptoPeppers project that I was involved in. You can see all the different indexes on the project, busy staking. So, you know, this is the largest amount of stake. It's 1.5 million GRT being staked to this one, and it kind of goes down. So there's a lot of indexes supporting this subgraph. We can see that there's only two curators. It's me and someone else. And this is what this API produces. It allows us to go and, come on, give me my schema. I'll just do it myself. So we can go and look at the different Pepes. There we go. There's my schema. So we can go and look at the different Pepes that are available here, and we can order by their ID, yep, and order direction descending, and we can look if it's wrapped. We can look at the metadata, like the description, name, and we can look at the current owner, which is the wallet, right? So these are like lots of different, and that's the GraphQL query language. You can see here that we have the first ID, which is Pepe 4095, which is wrapped, and that's its description. So we got the metadata from IPFS and we stored it here. Now, if I wanted to see, I know we're running a little bit over time, but if I wanted to see the first 10, which I own, right, where ID is.
Wow, that's an amazing session. Thank you so much, kids. Thank you. Like I had an amazing time. So we have a question in the comment section, and I would love to read it out, but it's quite long. The person really asked the question. So can you just check it and probably give a reply to the question? Thank you.
Sure. Does Graphs work like a database to store our data? It stores database based on the schema provided, have endpoints provided by Web3 API organizations. and users based on the endpoint provided by the input. Yeah, so something like covalence and simple hash, right? They sometimes use subgraphs, and they will essentially take the information from different RPCs, but the cost of querying a subgraph is a lot less than doing it by yourself through an RPC like Alchemy. I can show you a little bit about how the code looks, right? So look here, this is an NFT project. So we've got the NFT contract, we've got the start block, and we're just listening to the transfer event, right? So, and then it's the transfer event is run every single time we get a transfer event, it runs this handle transfer, right? And in handle transfer, we have availability of that event, right? And on that event, we've got lots of information that we can access, but like we also have the event parameters. So if I, for instance, give you an example of this, if I take this and I pop this in Etherscan over here, I can show you. Boom, boom. So that's the leopard NFTs, and we've got, for instance, this transaction over here, we'll have a log which has the transfer, right? And we're listening to this transfer, and we can see that it's coming from the 0 address to this person, which means it's a mint, right? So all NFTs, when they're created, they are transferred from the 0 address to someone else, and when they are burnt, they are transferred to the 0 address. Kind of think of like the black hole of the blockchain. In this thing, we can then, over here, we've got our schema. So we've got leopards with a bunch of information on it. It's a relational schema. So you can see here that I've got users, right, which have leopards, and we've got leopards that have leopard metadata, and we've got different transfer entities. We've got attributes which are part of leopard metadata as well. So little parts of their attributes, description. So this is our database schema essentially. And then what we do is we then create by going new leopard, pass in the ID, and we set all that information and we save it, right? And that will essentially save it to the database. It's like over every single transaction. Now, you can, when you're querying one of these subgraphs, right? To give an example, right? So this website over here uses that's the subgraph over here. And I think in pretty much since I deployed it, when was this deployed? 5 months ago? Yeah, like maybe last time I updated was 3 months ago, but it was deployed 5 months ago. And I think that it's probably used about maybe $15 to $20 in query fees since then. And, we have people going to this website quite often, almost like every other day. Something like Uniswap, and there are subgraphs for Uniswap that has tons and tons and tons and tons of users. That will obviously incur a lot more query costs. But you can see here in the last 30 days, it's really, there hasn't even been more than 0.0. It might have been 0.0.01. Right, so every query is like a minuscule fraction of a cent. I can show you the API keys and how much they actually cost. So I can just go.
Okay, yeah, I was about to ask if you'll be able to get access to the
So for instance, we've got like
yes.
In total, that website has basically queried 1,329 times since its creation, and done 22 GRT, which is actually $2. Yeah, so $2. Average query cost is 0.017. So that is times that by 0.08, and that is like the average query cost in dollars per query. It's very, very little. So yeah, it's a fraction of a cent. It's a tenth of a cent. Cool.
Thank you so much. Can you share the slide with the community?
I can't just yet because it's a slide that I use for working. But what I can do is we can share the recording.
All right, sure, no problem. Thank you so much. I think we have one more question before we go.
Yes. No, you don't need GRT to try the testnet out. So like if you go to, for instance, the hosted service up here, so you see in the top, if I click there, the subgraph studio is where I showed you now my API keys, and these are all my deployed decentralized subgraphs, right? But if I go to my hosted service, these are, you can add and create as many as you like, but if they aren't being used, they get removed. So I've got lots of ones where I do my testing, and I'm consistently creating new ones. So and you know, whether it's on testnet or on a live net, you can deploy them here, and it's totally free. And if you find one there now, if you go to this website here, if you go to this centralized one, you can query it here. But the minute that you start wanting to query it from you know, somewhere else, then you will need to get an API key. But obviously, if you reach out to people, they can provide you with maybe the developer API key, because I have access to the Studio API key, which is has a limit on it, but is also free to use. And what you can also do is, a lot of these subgraphs are open source. So when you have an open source subgraph, you can just deploy it to the hosted service if you find it. So it's quite simple. I'd love to, yeah, if you have any more questions, you're more than welcome to reach out to me on Discord. If you have Discord, I'll post my name in here now, in the chat. And you can also find me at BMAC on Telegram.
Okay.
And at Katie Fourie on Twitter.
Yeah, please share your link. Share the link to your socials.
Yes.
Thank you so much.
I know I've been going for a very long time. I really appreciate everyone giving me the time to kind of show you all this. I've been working in the ecosystem for a very long time, in the graph ecosystem, and I'm part of Builders DAO, I'm part of Indexer DAO and Advocates DAO, as a DAO member in all three of them. And I would be very, very happy to see all of you join if you're ever so inclined. So also a cool thing to show you this.
Thank you so much. One more question from Web3 Africa. I would like to know if there's a chance for internship, or if there's this chance for anyone in the community to join for internship or any other thing as advocates.
So if you join the advocates, if you apply to the advocates program, there are tons of educational sessions that are held there, and if you do make contributions, you can submit a contribution request and get paid for it. With regards to internships inside the other companies in the Graph protocol, I can't really say much about that. However, your first kind of entry point would be to, you know, jump into the Discords for the Advocates DAO, the Builders DAO, the Indexer DAO, especially the Advocates DAO, and look at maybe join some of the calls inside of Discord. Maybe apply if you're so inclined. We always are looking for more people in Africa to join, because we need more you know, events being thrown and those sorts of things, and those events will be obviously compensated. And then within Graphica, we do run educational workshops. So if you want to learn how to build subgraphs and substreams, that's the place to be, as well as also in Builders DAO. And you can find me in all of those Discords.
All right. Thank you so much. Thank you for the amazing session. Thank you for Web3 Africa and everybody. It's an amazing session. I think it's about time we wrap up now. It's been an amazing workshop, and we definitely share the recording with everybody. I really appreciate your time and everything and the knowledge you brought. Thank you so much. Okay, guys, we've come to the end of the meeting. Thank you, and see you in the next edition of our workshop. Bye, everyone. Have a great night. Bye.